extra credit on the final for reminding. So, do you remember how to deal with integrals like these? Basically, the exam will be full of integrals. If you're good with integration, boom, you pass the exam. It's really good. All the problems there are mostly about integration, area between graph 1 problem, and, you know, population is growing, all those writing problems and stuff, and one regression problem. So, if you practice integration, you will not fail the exam. I would say you will do well. I have high hopes on this Monday exam. X cubed gives you what? You can yell. Your chance to yell. Over 4. How about this guy? I would rewrite it as minus x2 minus 3. Do you remember that? 3 at the bottom becomes minus 3. And minus in front because there's a minus in front. Now it will be minus x to the minus 4 or minus 2?
Would it be plus now because it was minus?
Let's see. Minus 2 divide by the same thing right away.
Oh, you're including.
Yep. I'm going slowly. This is important. Did you understand this step? I'm integrating this piece now. So here it is. X to the minus 2 over minus 2. Plus, what is that? ln absolute value of x plus c. Can you do that? Can you recognize this in the, say, multiple choice? If you want to simplify x to the 4 over 4 plus, I can rewrite it as 1 over 2x squared plus ln absolute value of x plus c, but not necessary. Minus minus gives you plus, 2 is still denominator, x to the minus 2 becomes x squared. I see why it's jumping, yeah, the cable. Yes. Fear the Russian stare. No, still jumping. It's not afraid. Okay, keep going. Let's see. So they review these. How about the one when we have exponential functions? And you know, there's so many integrals to review, so the most important one is when you need to plug the points. Those are called definite integrals. Do you remember how to do from 0 to 2 e to the 0.2x dx? These kind of things. Exponential function gives you exponential functions, you just copy the whole thing. That's how you start. Copy the whole thing. And then you have to do some extra step if it's not e to the x. And it's not e to the x, it's e to the 0.2x. When you differentiate, you multiply by that piece. When you integrate, you undo chain rule. And that is why you divide by that piece. Does it make sense? Do you remember that? Copy, divide if it's not just one there. So you have to do that. Instead of plus c, you put a bar from 0 to 2 because it's a definite integral. Plug the top, that is going to be 0.2 times 2, 0.4, minus plug the bottom, e to the 0 is not 0. Many students do this mistake. E to the 0 is 1. And both of them are divided by 0.2. Can you do that? That is the answer. What do you think about that? I'm going fast because we learned this already. You're supposed to be a pro right now. Bless you. Oh, this one looks poor. Let's see. Nope. This one made it worse. Okay. I think it's not a computer problem. Yeah, it's a screen problem. So not too bad. What do you think? You got very quiet. That is bad. Can you choose this problem from the multiple choice? I give you the list and you just choose it. It looks kind of not too bad. And this one I want to take from the exam the super quiz. How is a super quiz? Very good typical problem. Super quiz says, find f such that. So we have, they want us to find f such that st, the derivative of f is given as 8 over square root of x. So, to get out of derivative to the original, you integrate. But that will give you some function plus c. So that's a family of functions. Don't be late for the exam. 12:10 on Monday. So that is why they give you initial condition. And that makes the problem called initial value problem. At 16, apparently, it is 71. That is called initial value problem, IVP, because they gave you the initial value to make sure you have exact solution, not a family of functions. But in general, what's the first step? The first step is always the same. You need to integrate. If you want to go from derivative to the original function, you integrate dx, right? So let's integrate this given derivative. F is integral of 8 over square root of x dx, indefinite integral, so we don't know from where to where. Let's do that. How do we integrate that? If you're afraid of fractions, if you're afraid of radicals, rewrite it. Do you know that I can do it 8 can be pushed outside, because it's a constant. Now I have 1 over square root of x, that is x to the minus 1/2 dx. See my lecture 0, I told you it's going to be very important to be flexible with radicals and roots in general. That's why in the very first lecture I'm reviewing these properties really well. Now, 8x to what power? We're adding 1, subtracting 1. What is going to be? Minus 1/2 becomes what? Just 1/2 or minus 3/2. If you don't know, take a pencil and write down no, not like that. Over here. Minus 1/2 plus 1. X to the minus 1/2 plus 1 becomes just 1/2. Thank you. And you divide by 1/2. When you do it many, many times, you understand that that's just times 2. Plus c. So let's rewrite it. 8 times 2 square root of x plus c. Because x to the 1/2 is the square root of x. That is 16 square root of x plus c. Unfortunately, this plus c means we found a family of solutions, a family of square roots. So it looks like that. The square root at 0 is 0, so it's this one, or shifted up, or shifted up, or shifted up. If c is 100, it's shifted up. If c is minus 5, minus 10, and so on, it's a family of solutions depending on what c it is. If it's c 0, then it's here. To choose the particular solution is called general solution versus particular solution. We will be using this given knowledge that at 16 it is 71. Only one point at 16 exists on the curve that gives you 71, and that one point will fix the solution because they don't intersect. So that was step 1, integrate. Step 2, we know. So this was my f. I found f, but this is a general solution. This is also introduction to the differential equation class, by the way. We know that f at 16 is 71. And that will give us to fix the particular solution. Don't be late for the exam, please. It's on Monday at 12:10. You will kind of lose your own time on the exam. So, f at 16 is 16 times the square root of 16 plus c. As you can see, it's not always 0 or the number we gave you. In your homework, it's very common, it's the same number. No, it's not going to be 71 anymore. So let's calculate. This is supposed to be 71. And you solve this equation. We know that at 16, it should give you 71. But when you plug 16, it ends up to be 16 times 4 plus c. Thus, c should satisfy this equation. Solve for c. Solve for c. And c is 71 minus 64 is 8. Yeah? No? 7? Yeah, thank you. I was pretty close. C is 7. Answer. f in general is 16 square root of x plus c, which is 7. Can you do that? Can you do this problem on a test? It's a very classical problem for the test, so that's why I wanted to give it away, because it's not a secret, it's going to be there. It's very classical. We'll give you this and the point. Integrate, plug the point, choose the solution from the multiple choice, or write it down. What do you feel about this? So this was from your super quiz number 6. It was the 6th problem in a super quiz. Yes?
For the exam that's coming up, is it going to be the same format as the other ones?
Yeah. Exam is same format but longer, so it has 10 multiple choice and 3 free response. Kind of actually sounds the same, right? Yeah. Oh, okay. No, because we have 3 midterms. Oh, exam, to be honest, is not that bad. I actually very optimistic about the exam. I think it's better than the very first one with limits, because limits were confusing and asymptotes and stuff. This one, I'm very optimistic. I want you to all get 100. If you get 100, that would be amazing. Because can you do that? So that's already cool. Like if you can integrate, boom, you have lots of stuff done. More examples. More examples. Let's do 3. I'm usually very honest if exams are hard. So for my engineer students, I told them the exam is very hard. It has everything. For this one, I'm actually very happy about this exam. It's good. What do you remember about this? X sine, that's also your super quiz. 8 minus, so I'm kind of solving your homework for you, to be honest. 5x squared. 5x squared equals. How about this one? Dx, I forgot dx. Did I tell you an appropriate, I forgot to tell you an appropriate joke about the integral. Did I ever tell you? Okay, now it's time. I think I promised you. Not to forget the dx, there is an inappropriate joke I learned in the United States, so it's funny. The teacher goes to school in the morning to work and passes by a bad neighborhood. And the bad neighborhood has lots of graffiti there with lots of inappropriate words and everything. And he's passing by and he sees this. And he's like, no, how come you guys, you should not write it. This school is on the way, kids are passing by. He says, how come so wrong? Never forget to put dx. So he sees this as an integral e to the x dx. That's a good joke. The thing is, you can put dx and now it's not inappropriate anymore. So he says it's like this, it's like that. He says, I always keep telling you, don't forget dx. So I just forgot, you see, and that kind of triggered my memory about the joke. Now you know. I was telling this joke to my online students, and then someone put it in chat. My mom was passing by when I was writing this, and she's like, what the heck? Yeah, anyway, now you know the inappropriate joke. Don't forget dx, or else it becomes inappropriate. How would you solve this one? That looks horrible. What would you do? Multiple choice. Usually this is multiple choice question, and you have like A, B, C, D, and none of the above answers. How would you choose? Lots of integrals, so it's like hard to guess.
Well, first, we need to integrate by parts.
Integrate by part. We basically learned 2 ways of integration. Integrate by parts, use substitution. In Calculus 2 class, you learn much more in numerical integration, fraction decomposition, trigonometric substitution, and so on. Sometimes even putting some arc sign inside of the integral helps, surprisingly. So you only know 2 methods. Let me write it down. We only know either u sub, so you guys kind of don't have lots of choices to think about, or integration by parts. So step 1, panic. Step 2, choose out of these 2. So just don't stack in the first step too much, right? Like maybe try each and see how it goes. Integration by parts says, 2 pieces should be completely not related. That's how you know that you shouldn't use integration by parts if pieces are not related at all. But if you see some piece looks like derivative of another piece, you should do your substitution because it's undoing chain rule. So which one would you prefer?
Integration by parts.
So we have 50-50 basically. If you do integration by parts, Liate tells you to choose x to be u, and this will be dv, and you can try. Maybe it will work. All this will be dv. Someone says use substitution. I agree with that one. because I see that x looks very close as a derivative of 8 minus 5x squared times or divided by a constant. So looking close. Thus, maybe we are doing chain rule here, and that's how you try. Let's do it this way. If I choose everything inside to be u, one more hint actually, sign of something inside and that something is complicated, usually that is u substitution. Because sign has like a thing inside, you don't like it, you want it to be sign of u, so you say let u be 8 minus 5x squared, and that will make it sign u, and so that's how you know it should be u substitution. Du is minus 10x dx, like so. You need to have minus 10x dx, but you have just x dx. And that's how you know you're very close to be correct. So, you guys, I think most of you know, like solving for dx. Dx will be du over minus 10x. Plug the first equation and the last equation into the integral, and you basically perform a transformation. Transformation from the previous integral, now we have sine of u, that was the whole point. You see how nice this integral looking. Dx is du over minus 10x. X cancels out with x. Let me put it in light green. X cancels out with x. So I just have du minus 110, and that's what I usually do. I put it outside. But does this make sense? Do you remember u sub? U sub? If you don't put right now a huge exclamation mark, which is not a factorial, and review it home, you have like 4 days to review this. U sub, review it because it's going to be there several times. Solving u sub, it will be 1 over minus 10. Integral of sine, oh, just a second. Integral of sine is either cosine or minus cosine. To check, you quickly differentiate in your mind. Derivative of cosine is minus, so that's how you fix the problem, but put parentheses. No bar, so it's plus c. But then the last step, which you could skip, you could just plug u right away. It's going to be minus minus gives you plus 1/10 cosine of whatever your u is. You the only one who knows what it is, so you better plug it back. 8 minus 5x squared. And the beauty of this is that if it's multiple choice, you can check your answer by differentiating this. If you differentiate this, it should give you whatever is inside of the integral. So technically speaking, if you have way too much time on your hands, you can differentiate all the multiple choice answer and choose the correct one.
I mean, I guess you could do the same with the response.
Yeah, yes?
Can you explain why you canceled out the x?
Yeah, that's the tricky part, I would say. I was expecting if someone gonna ask. Thank you for asking. Let's do this again slowly, because I skipped it. I did it like so. Let me see. When I'm plugging in, say x stays there, sine u is inside, dx have to be changed using this formula. So we changed u. U is 8 minus x squared. Now dx. dx is du over minus 10x. And we hope that all integral will be only in terms of u, and it's exactly how your substitution works. It cancels out this x. Make sense? Yeah, that's a good question. And that's the goal of your substitution, is to get rid of the other variable. We'll teach multivariable integration in Calculus 3 class, so before that, you were not supposed to know how to do it. Li-a-te. I actually made a typo here. Good. What do you think about this? U sub. It kind of looks scary, but it is doable if you do it many times. So I just hope you will do it many times. And then that's how you become good at it. Let's see. I'm checking one, your super quiz. Yeah, the applicational problems and stuff. Finally, let's practice with, let's jump into integration by parts to have some kind of comparison. Integration by parts right now has 2 questions on the test. One just asks you what to choose to be u, and that's why Liate is magically helping you. The other one is actually show everything. So, what kind of good problem is here? Seriously, none of it? Okay, fine. The classical integration by parts problems are when they have product of 2 not related two not related functions. So let's see that. Well, I already gave away that I'm going to do integration by parts. But in general, you're supposed to know it by yourself. If you have integral something completely not related, so x sine x dx, those functions have no relationship. That's how you know u sub is not going to help you. Derivative of one of these did not give you anything looking close derivative of another one. The other very good example is ln x and sine. These have no, or cosine doesn't have to be, some kind of trick. These have no connection at all. So also, and that's why Liate is working really well, because it says if you see log, usually they're not related. Inverse functions like arcsine, algebra like x over here, or 5x, let's do 5x, and so on. And so on. So these products have no relationship, and that's how you should do integration by parts. So this is a very classical one. Oh, one more classical one is with exponential function. Exponential function, let's do this example. Oh, actually, I want to do sine, to be honest, but it's fine. E to the 5x times cosine 7x. These have no relationship. They're also very classical example. So these are three classical examples: algebra and trig, log and trig, exponential and trig. Or exponential and let's see, this 1, 2, 3. One more classical is x times e to the 7x. That is algebra and trig. Also no correlation here. Sometimes there is a correlation, but not in this case. Yeah.
On the test, we can see like arcsine or recursive.
Nah, I will not put it there. Yeah. Even if it's there, I will probably change it just to sine and cosine. So the question was, should you remember arcsine and arctangent? It's nice if you do, but not for the test. Let's not fail people just because you forgot the integral or derivative of arctangent, right? That is a very expensive mistake. So let's do it. So let's do which one? I like the one with e and cosine. Let's do this one. Solution. Since they are not related in any way, for last one I wanted to say if there is x squared, actually that is u substitution. Do you see that? If it's 7x squared, then x is a derivative of x squared, kind of. So you could do it with u substitution. So you should be careful with this. If there's no relationship, then there's no relationship. So that's kind of a tricky part. Maybe like square root definitely will help. Then that's it. There's no relationship there. But e and cosine, no. Only in upper level math we actually give you relationship between exponential function and cosine, specifically in imaginary numbers. It's pretty cool there. Solution. We choose to do integration by parts because I don't see any connection between functions, and integration by parts undoes product rule. So it is a result of the product of two functions, differentiation of the product. Liate is an amazing way to choose what to make u. Again, you just name things here. That's not a transformation. You just, unlike u substitution, you just call things out. Liate says if you see log, choose that u. I don't see it. Inverse, I don't see it. Algebra, also I don't see it. Make sure you understand that we have two functions here, not four. It's exponential function with 5x inside and cosine with 7x inside. Do not use integration by parts for the things inside. U substitution is made for that. U substitution will handle this part. But Liate, integration by parts, handles the products. So that's important. It's a product. So no log, no inverse. I don't see algebra. I see trigonometric function. So only then, if there's no other choices, you choose exponential to be u because it's very not helpful usually. Oh, it's such a bad example. I just realized it's a recursive example. Do you remember in your homework you had a recursive example?
Oh, yes.
That will take like 20 minutes to solve. I just realized that right now. Oh, it was such a good idea. Okay, then don't choose this one. Let's choose something faster. Oh, log is good. Let's do log. Log will not be recursive. Okay, good. Log is good. But let's make it more interesting. I wanted to practice what to do with 5x and log of 7x. So let's do this one. I will just rewrite it for you. Solution, let's just do this one. Integration by part, Liate. Example. Integral of ln of 7x is multiplied by cosine 5x dx. Recursive integrals are fun, but they take lots of time, so you will not see them on a test.
Fun.
Yeah, that's the definition of fun, right?
I mean, yeah.
U will be chosen in the order of Liate. Liate says, I see log, choose log to be U. And ignore things inside. That will be handled by U substitution. Let's U be ln 7x. Immediately find derivative. du is, and that's where it's supposed to remind you, derivative of log is 1 over everything inside. 1 over everything inside, and this is where you can make a mistake. dx. What is missing? 7. Chain rule says times the derivative of the function inside. Derivative of 7x is 7. And that's why it's just 1 over x actually. The 7 got taken care of itself, cancel out. This is not the end. U substitution would be done here, but this is integration by parts. So we keep going. You differentiate it, now you integrate. When you chose this to be u, everything else automatically becomes dv. dv is cosine 5x dx. Now you integrate, and that's why integration by parts is pretty cool, that you differentiate and integrate in the same process. Integral of cosine is either sine or minus sine. I don't remember which one, so I'll write down, copy the part inside, and now check. When you differentiate sine, it's plus cosine, so I will keep it positive. But that's not the end. Don't forget, when you integrate, you undo chain rule, so you need to divide by this leading coefficient, which is 5. And these are the two common mistakes. Chain rule was lost at the u part, multiply. And then chain rule can be lost at the integration part, divide. Yes?
A natural one with x is just be 1 over x.
Yeah, just 1 over x, yeah. That's a cool property of log, that this inside part cancels out. Cross product minus bottom, that's how usually people visualize it, equals. The first part will be a ready part. We finished integration for the first part, so I don't write any integral sign here. Minus is part of the formula. The second part, the bottom product, is an integral, so I have to put integral sign. This thingy in the corner shows up twice, so I'm just copying it one more time. Sine 5x over 5 times 1 over 7x times 7 is just 1 over x dx. And it is also not an easy integral. Such a bad example. Triggered. Huh?
Isn't the integral 1? Isn't there a rule that says sine x over x integrated this 1?
Yeah. That's the one, the famous one. It's just kind of not a very good example because it's too hard. People will not be able to do it. I just realized that. So the idea of integration by parts is the first piece is ready. It gives you a ready piece, and the other piece is hopefully an easy integral. If it's not, on a test it will be, of course. Integral. Hopefully it's going to be an easy integral. And on a integral, what is wrong? Okay. So on a test you will have it easy. In this case, it's a very famous, you're right, yeah, it's sine 5x over 5x, which is what? Well, it is, the limit is 1. The integral, yeah, you're right, it's a famous limit. It's actually called a famous limit. If you repeat again integration by parts, Liate tells you to choose 1 over x, and it's a recursive integral again. Yeah, okay, fine. Anyway, you guys got it. The easy integral will have something that we did before. I just was trying to choose some kind of cool example, and then I didn't.
Can we do it anyway?
Yeah. So, and then you continue. Continue if you can. So just not a very good example. It's fine. The idea is to review integration by parts and know what's happening here, so it should be fine.
And we keep finding examples, or we keep finding examples that try to be.
For the exam, I've given good examples, and that's why I cannot give them away. So I'm trying to make up something in my mind, and it was not successful. Sometimes it's not successful. However, do you know what is successful? Are the problems about population growing, stuff like that. And you guys like these problems. So let's review that. We reviewed your substitution, integration by parts. Practice a lot. Just practice lots of stuff from the quiz, and you should be fine. But if you actually check this file, I already posted it for you. It looks like that. It's called Exam to Review. It has lots of questions to practice. What is the integral of 5x to the 7? What is the integral of 3 over x to the 5? That's exactly what we just did. Sine of 4x. Practice this. Ignore secant, cosecant. We're not going to do it there. Sine and cosine, you need to know. That's true. Integral of 6 cosine 6x. Practice that. And then these your favorite problems about the population. So I'll just briefly copy it, but you guys write down something. That the population example. The population, it is number 13. Do you see it or not? Number 13. Nice. You don't have to write down everything. The population of a small town is P prime T. If it's P prime, then the rate is given. So we kind of recorded how many people we have growing instead of actually the number of people. That is different. The population rate is given. Here it is. P prime is 26e to the 0.024 t, where P is the population and T is the number of years after, and that's what you should be good at because we did it so many times. T is number of years after some kind of year, and they chose it to be after 1995. So at 1995 T0, the population at the beginning of 1995 was given.
What are rhyming about?
The population of a small town at the beginning, yeah? At the beginning of 1995.
I don't see where you're writing.
I know, but you can copy it over there. I will show you in a second.
Also, it mentions rhyming sums. I don't think we ever covered those.
No, that one you can skip too. Whatever you don't recognize, you can skip. But you need to concentrate here. This one is important. Was given as 5800. Finally, the question. So for now, I think you guys recognize this. What is the question? Estimate the population. And we don't have population, so we need to integrate P prime. And then when at 2016, so it's going to be it's going to be a different T. And then round to the nearest person. Nice. Looks like that. That is my short way of writing it down in an ugly way. Population rate is given as P prime. The formula is exponential growth. We know that population is usually modeled exponential growth. 26 times e to the 0.025 t, 24 t. T is the number of years after the 1995, and the population at 1995 is also given. Find, and that's what they don't explain, so you have to understand yourself. Find the population. If there's no rate and there's no per, that means it's P, the original function. Find the population when? At or on 2016, at the beginning of 2016. Solution. And you guys like these problems, I know that, because you're doing them really well, usually on a test. So practice this, it will be at least one problem like this on a test. Let's write down what we have. We have a derivative of P. The derivative is a typical exponential growth model. It's growing with the rate 0.024 t. This 0.024 is kind of growth rate. We also know that when t is 0 in 1995, t is 0. P at 0 is 5800. Do you all agree? P at 0 is given. And then they ask us to find P at, now I have to calculate, what is my T in 2016? Which one? 21, thank you. 21, it's glitching again, is a question mark. 2 steps, integrate, plug in to find your C, plug in the number they want us. It's exactly what we just did, and I call it initial value problem. It has extra step at the very end. But you first integrate, you will have answer with C. To find C, you use it at 0, it's 5800, and then at the very end, you plug the number they gave you, 21. Can you do that? What do you think about this? This is number 13. Number 13 on the exam review. So let's do it. Integrate really fast, plug in and solve. And that increase. Do they say actually to find or create the integral?
So should we just start by...
Write the expression B. Oh, they just say write the expression. Okay, that's not interesting at all. They say write the expression. Oh, okay, fine. So write the expression including an integral that would find the population of the town at the beginning. La la la. Fine. Solution. Let's integrate really fast and move on, because kind of the idea is the same and it's not so many new interesting things here. Let's see if you can catch up or do it faster than me. P is integral of the function which is given. So P is integral of 26. Why are you glitching? 26 times e to the 0.024t dt, which is copy the constant, copy your exponential function, but don't forget to divide by the leading coefficient. Leading coefficient of the exponent is 0.024 plus c. Plus c. I would also simplify. To find the c, I will plug 0, and that will give me 5800, but it also gives me e to the 0 is not 0, remember that. That will be 26 over 0.024 plus c. Thus, that is my c. Solving for c gives you 5800 minus, what's the number? Did you calculate, Chris?
1083.3 repeating.
Let's keep it exact then. 26.
I could probably. I mean, if you'd really like, I can. If you'd like a bit simpler, do on 250 over 3.
Yeah, that would be better, but it's too late. So this is my c. P then is the function 26. Let's hurry up. 26 over 0.024 e to the 0.024t plus c, and my c is this function I just found. So now what they want me is to plug in a new number, and the new number is 21. 21 is the numbers of years after 1995 till 2016. So the last step will be find P at 21. Wow. My tablet is like, nope, I'm out of here. What do you think about this? So plug in and calculate. Not too bad. What do you think about this? Very nice question on the exam, to be honest. I think the students usually do well here. So we reviewed integration by parts, use substitution in the initial value problem, kind of even twice, because this is also going to be there. Finally, definite integrals, plug the top minus plug the bottom. That is kind of the whole exam, to be honest. The other parts we're going to review on Friday, working more with the regression and area between graphs. Area between graphs is the topic that students struggle, so definitely don't be late on Friday. And exam on Monday is at 12:10, so don't be late as
So we're
well.
not solving the actual solution for 21?
Thank you.
I mean, I guess that's not really relevant.